Okay, today's lesson is on something called age problems. It's actually a classic. This is a classic problems. It's really help student to really understand algebra because we are going to use that to solve those problems. And now when we do algebra, if we uh, if we are not able to do word problems, that means we don't really learn algebra yet. Uh, so let's see how we do that one. Our first one, you said that Jill's age is 1/5 of her father's age, and the sum of their ages is 48. And asking how old is Jill? Well, since we don't know Jill's age, when we do algebra, we just set as a variable. So we call x is Jill's age. Now, because Jill's age is x, so therefore, and that's 1/5 her father's age. Therefore, her father's age, then that will equal to 5x. So even though we don't know Jill's age, we don't know her father's age, we know the relationship. And they said that if we add them together is 48. Well, so we translate this first sentence into here, help us set out the variables. And then we're going to translate the second sentence. The sum of their ages is 48. Then we know that x plus 5x is equal to 48. Now this is the equation. So when we doing algebra, we basically is about how setting up the equation and then solving them. So x plus 5x, we know the 6x, that equal to 48. Then we divide by 6 on both sides, then x is 8. So Jill is 8 years old, and her father will be 5 times 8, 40. Now 40 plus 8 is 48, so we know we got that right. Okay, and here's a problem you can practice on. Since we are not in class, we'll just work it out here. Okay, in this case, it's going to be different. Jill's age is 1/4, our father's age, and the sum of their ages is 60. So we change that to 1/4, change that to 60. Now the setting up is still the same. X is Jill's age, and her father's age then will be 4x. So 4x, her father's age. And then the sum is 60, so x plus 4x is equal to 60, and that will be pretty easy to solve. That's 5x equal to 60, divide by 5 on both sides, then x is 12. So Jill's age is 12, her father's age is 4 times that, would be 48. So 12 plus 48 give us 60. So we know we got that right. Okay, so this can help us with the variables and very help us set up an equation. Then we can just solve linear equation. You can see that with a linear, you use algebra, we can solve this kind of problem pretty easily. Otherwise, you have just going to be try and error and take a while to figure it out. I mean, it's not impossible, but it's going to take a while to figure it out. But now we just using the solving a linear equation and get our answer. Okay, so we have that. Now we're going to looking at a second type of problem, and here it says that this problem. So the sum of Sam and his sister's ages is 20, and Sam's age is twice his sister's age minus 1. How old are Sam and his sister? Okay, so we actually dealing with two variables. One is Sam's age, And her sister, let's call it the Y, that's his sister's age. And now we know that's a relationship between these two is x plus y equal 20. So that's our first sentence. We translate that. Then second sentence is Sam's age is twice his sister's age minus 1. So that means x is twice her sister's age. Her sister's age is y, so 2y, then minus 1. So now we actually got two equations. Equation 1, equation 2. Two variables. But you can see that x and y have relationship. X is 2y plus 1. So therefore, we can replace x with 2y minus 1 to this first equation. So the first equation becomes 2y minus 1, which is our x, plus y equal to 20. Now we only have one variable. So 3y plus y, 2y plus y is 3y. And minus 1 is 20. So this is simple linear equation. We just add 1 on both sides. Then we got 3y equals 21. Then we divide by 3. Then y will be 7. Okay, so Sam's sister is 7 years old. And Sam is twice minus 1. So that will be 2 times 7 minus 1. That will be 13. And you can see that 13 plus 7 is 20, just like in the problem. So this one, Sam, without algebra, is going to be hard to figure this out. Okay, we're going to see another exercise on this. So this time, the sum of Sam and his sister's age is 30, and Sam's age is twice her sister's age, minus 9. So we change that. Then how old are Sam and sister? Okay, well, let's see. Same thing. We got x as Sam and y, his sister. That's their ages. Sam's. Yep. And we know x plus y is 30. Very good. And we also know x is 2y minus 9. So now we're going to replace x with 2y minus 9 and plug into this equation. So that becomes 2y minus 9, which is our x, plus y equal to 30. Then 2y plus y, 3y. 3y minus 9 is 30. Then we add 9 on both sides. Then 3y is 39. Then we divide by 3 on both sides. So therefore, y is 13. So Sam's sister's age is 13. And Sam's age is twice of that. 2 times 13 minus 9. And that gives us 26 minus 9, which is 17. And you can see that 17 add 13 is 30. So we got that. Figure that out. Okay, and now we're going to looking at another type of the problem. Here is Nora is a year younger than Chloe. 18 years ago, Chloe was twice as old as Nora. How old are they now? Well, so same thing, we're going to set variables. So x will be Nora's age, and y is Chloe's. And we now we know is Nora x is a year younger than Chloe, so x is y minus 1. But 18 years ago, Chloe was twice as old as Nora. Oh, 18 years ago, how old is Chloe? Well, that would be y minus 1, right? 18 years ago. And then 18 years ago, then Nora will be x minus, oh, sorry, minus 18, y minus 18, 18 years ago. Then will be x minus 18, but we said that it was twice of that back then, so times 2. And now we have this y minus 18 we can distribute 2 into it. So we got 2x minus 36. So now we got this equation, two equations, two variables. Then that means we can have the solution. So it really doesn't matter which variable we're going to substitute. In this case, it looks like probably easier to substitute y with x. So based on this, y then will be x plus 1, right? We just add 1 on both sides. Okay, then we're going to plug this into this equation. Then we got x plus 1, which is our y, minus 18 equals 2x minus 36. So on this side, left-hand side is x minus 17. On the right-hand side is 2x minus 36. Same, that's just linear equations. Now, if we minus x on both sides, what we got negative 7 on one side. That side is x minus 36. So for this one, we can, because it's an equation, we can flip around. So we can, that's the same. So negative 17 equal to x minus 36 is the same as x minus 36 equals negative 17. So now we just add 36 on both sides. And we know x will be 36 minus 17, that would be 9, so 19. And our x is our, is Laura. And so therefore y is Chloe will be 20. So Nora is 19, Chloe is 20. Well, let's see. 18 years ago, Chloe will be 2, and Nora will be 1. Well, it is. Nora was twice old as Nora. Oh, sorry, Chloe was twice old as Nora. Okay. Now we're going to see the same problem, but in different numbers. So in this one, it's our practice. So in this case, Nora is 2 years younger. That's 2 years younger than Chloe. And we're now talking about 15 years ago. Chloe was twice as old as Nora. How old are they now? So now we're going to set up x as Nora's and y, that's Chloe's. And then we know x is y minus 2. And 15 years ago, Chloe was y minus 15, and Nora was x minus 15, but Chloe was twice old, so we got 2 times that. So we got 2x minus 30. Now, here, based on that, we know y is x plus 2. So we're going to replace y with x. So now we got this side, left-hand side, going to be x minus plus 2 minus 15 equals 2x minus 30. Well, x plus 2 minus 15, that's x minus 13 equals to 2x minus 30. Now, same thing, we can flip it, and 2x minus 30 equals x minus 13. Then we minus x on both sides. Then we got x minus 30 equals negative 13. X got canceled. And we add 30 on both sides. Then what we got here is x equals 17. Okay, now Nora is 17, so Chloe is 2 years older, so that'll be 19. So y is 19, that's Chloe. 19, Nora is 15. Now, sorry, 17. Now, 15 years ago, and Chloe will be 4, was 4. And 15 years ago, Nora was 2. So Chloe was twice old as Nora 15 years ago. Okay. And Now we're going to see two more this type of problem, and this actually had to play with understanding a number, property of numbers. So we can see that Jack's age is double digit, but not as old as his brother, who is 31 years old. So we know Jack's age is a double digit. So we say X is A and B. Okay, two digit. We don't know what they are. We're trying to figure out. But we know X has to be less than 31. Okay. Now, if you swap the tenth and the units digit, so basically the tens and the ones digit, we get a new number, but that new number is Jack's age minus 9. So what is Jack's age? Okay, let's see. We know it's x, y. X is a, b. Could it be 12? Could it be 27? And we know there's two digits here. And now, because I have two digits, the value of this will be 10 times a plus b. That's because of what base 10. Like here, 12 actually is 1 times 10 plus 2. 27 is 2 plus 10 plus 7. Okay. So that's his age, the value of x. And the new number, we swap it, become b and a. So the value of that is 10b plus a. So this is a new number. This is Jack's age. I said that new number is Jack's age minus 9. So that means we got 10b plus a is equal to 10a plus b minus 9. Okay. Let me actually write down here, probably 10b plus a equals 10a plus b minus 9. Okay. And then we can see that we got two variables, a and b. And if we minus 10a on both sides, what we got here is 10b minus 9a. 9a minus 10 is 9a. There's a b here, minus 9. Now we minus b on both sides. So we got 9b minus 9a equals minus 9. Then 9 is a common factor. We divide that. So b minus a is negative 1. So b then will be a minus 1. So whatever number is, this is one's unit, one's digit, is the tens digit minus 1. So we can see it could be 1 0 or 2 1. That's this one. The unit digit is one less than that. Okay, and so now let's check this answer, 21. It could be 32, but we said is less than, is twice, I'm sorry, it's less than 31, so we cannot have that. So it's 21. And then we can see if does that work. If it's 21, we'll find that one answer is 21, see if that working. So we can see 21, if we flip it, it's 12. Now, 21 minus 9, it is 12. So the new number is 9, is his age minus 9. Okay, so that's what we got. Now, so here we're doing something different. Now we still is double digit is in the in the teens, but not as old as his sister, who is 25. Okay, and so Jack's age then is A, B, which the value of that is 10 times A plus B. And if you flip this, swap the ones and tens digit, then we got 10B plus A. And this new number then is Jack's age plus 45. Well, let's see. And so we're going to have the 10B plus A is 10A plus B plus 45, because that's what told us the new number is Jack's age plus 45. And we did the same thing. We minus 10A minus B on both sides, minus 10A minus B. So what we got is 9B minus 9A equals to 45. And if we divide by 9 on both sides, then B minus A equal to 5, then B is A plus 5. Okay, now let's see what we have. If A is 1, then B will be 6, so 16. And flip it, 61. 61 minus 16 is indeed 45. So that works. And and we know that it has to be 1, okay, at least. But the A cannot be 2, because if it's a 2, that's 27, which is older than her sister, who is 25. So that's why we know we only have one solution. The answer is 16. Okay, now we got one more problem. So on this one, Alice, in this case, he also at 2-digit her age, but we say that the sum of the tens and the first digit is half of her age. So her age will be 10A, just like we did before, plus B. And they said that add the first digit and tens and units digit, which is just A plus B, that is half her age, half of 10A plus B. Okay, so what we have now, we got this one have if we times 2 on both sides, we got 2A plus B equals 10A plus B. Then we have 2A plus 2B equals 10A plus B. And so what we got here, then I'm going to rewrite it here. 10A plus B is equal to 2A plus 2B. Minus 2A, we got 8A plus B equal to 2B. Then 8A will be B. So we know the digit, each one has to be less than 10. So therefore, A can only be 1. Okay, and A cannot be 0, because if A is 0, B is 0. So now we know A is 1, B is 8. So her age is 18. Well, let's see. If we add 1 plus 8 is 9. 9 is indeed half of the 18. So that's how we solve that one. Okay, let's see a different number. We do the practice. Same, the sum of the tens and first digits is half her age minus 1. So that's the only difference. So we got A plus B is half 10A plus B. So that's the value when you have those 2 digits, and minus 1. So times 2 on both sides, we got 2A plus 2B equals 10A plus b minus 2, because we times 2 on both sides. That means have times 2 here. That 2 and these 2 cancel, and 2 times 1, negative 2. So same thing we got here is, we can rewrite that 10a plus b minus 2, just flip it, 2a plus 2b. So minus 2a on both sides. Then we got 8a plus b minus 2 equal to 2b. Then minus b on both sides. And also add 2 on both sides. So therefore 8a is 2b minus b, so it's b plus 2. Now we can see that same thing, a cannot be 2. So the only number a can be is 1, a equal to 1. And in that case, then b plus 2 will be 8 minus 2, then b will be 16. So let's see, 16. Well, 16, when you add them together, is 7. Half of the 16 is 8. 8 minus 1, it is 7. So we know we got that right. Okay, all right. I'll send you the homework. It will be posted on the Google Classroom, and I also will send that to your parents. Okay, I'll see you next week. Bye.